Hi guys, I'm going to do number 3 right now, so if you got this wrong or right and want to watch the video to review, this is a question where you do need to use a probability tree. All bags entering a research facility are screened. 97% of the bags that contain forbidden material trigger an alarm, okay? 15% of the bags that do not contain a forbidden material also trigger the alarm. If 1 out of every 1,000 bags entering the building contain forbidden material, what is the probability that a bag that triggers the alarm will actually contain forbidden material? So I state what needs to come first. You either have to have the stuff or not have the stuff. Then the alarm will be triggered. Okay, so that's what I wrote down first. Forbidden material or not forbidden material. The probability of having forbidden material bringing it along is 1 out of 1,000. So there's the probability right here. How did I figure out this 999 out of a 1,000? Every branch needs to add up to 1. So 1 minus 1 out of 1,000 gives you 999 out of 1,000. From there, you have 2 things that will happen. Okay, so if you bring forbidden material, you'll either trigger the alarm or not trigger the alarm. It states in the problem, if you bring forbidden material, the chances of triggering the alarm is 97%. That means of bringing forbidden material right here and not having the alarm go off is 0.03. How did I get that? Remember, the branches again need to add up to 1. We don't get this 0.03, but we do get the 0.97. So 1 minus 0.97. All right, next, they tell us that of people who don't bring forbidden material, the alarm gets triggered 15% of the time. So that means no alarm will be 1 minus 0.15, which is 0.85. Okay. Next, before you even answer the question, go ahead and multiply across. This is a sequence of events. So I'm going to multiply 1 divided by 1,000 times 0.97. This right here, and I'll highlight it. This is the probability of triggering the alarm and having the forbidden material, 0.00097. In a different color, I'll highlight having forbidden material and not triggering the alarm. I multiply across and I have 0.00003. Okay, again, not forbidden and having the alarm, 0.14985, and then not forbidden and no alarm, 0.84915. And let me get this in a different color actually. Okay, now we have to actually answer the question that they asked. They say, what's the probability that, oops, there's my Algebra 2 stuff, sorry. It asks specifically, it says, what is the probability that a bag that triggers the alarm? So it doesn't say what's the probability that we will trigger the alarm. There's a given information. What's the probability that the bag will trigger the alarm? Okay, right here. So that's our given. What's the probability they actually have the forbidden stuff? So the trigger part, you can think of this as my denominator. I have to think of every which way that the alarm will be triggered. The alarm will be triggered in the yellow, okay? And that's my error right over here. So I'll re-highlight it or I'll circle it. I'm triggered right here at 0.00097, and the alarm also gets triggered here at 0.14985. So that's my denominator right there, and you can see, okay? So out of all the ways that I get triggered, or I can trigger the alarm, I want to know what's the probability that it's also forbidden and trigger. So that's what I need to look for, and that is right here. That's my numerator. When I multiply that out, I get the letter B, 0.0064. Let me know if you have more questions, and hopefully that kind of cleared up some probability tree stuff. Thanks, guys.